Hello, and welcome back to my Kubernetes series. In this video, we will get started building the Kubernetes cluster. We will install the first virtual machine, or VM as I will call it going forward, change the settings to fulfill Kubernetes requirements, add the Kubernetes repositories and install the Kubernetes components, clone that machine, adjust the settings of each VM to ensure they are unique in regards to host name and static IP. Lastly, join these machines into the cluster. Don't worry if you were not able to follow that quickly. We will walk through the configuration slowly so you can follow along in this video or even pause if you need to. You heard me using the term node. As one of the fundamental architectural pieces of a cluster, let's go over what node is first by taking a look at the Kubernetes website. Kubernetes runs your workload by placing containers into pods, which are then run on nodes. A node may be a virtual machine, as what we will be using in this series, or a physical machine, depending on the cluster. Now that we know what a node does, let's take another look to make this concept a bit clearer. The diagram you see represents a cluster, which is the blue shape. Each cluster contains individual nodes which execute the work as we learned before. These nodes can be VMs, which is what we are going to use in this series. They can also be LXC containers. Each node runs some fundamentals, such as a container runtime and the kubelet. This diagram still refers to Docker as the container runtime, but we will be using containerd. The kubelet coordinates the communication with the control plane and executes what you want it to do. That is just a quick overview of the architecture of a cluster. If you want more detail, please feel free to take a look at that very extensive documentation on kubernetes.io. It is definitely worth your time and a great source of information. Now that we have gone through some fundamentals, let's get going, create the VMs, and install an operating system. In this series, I will create 5 VMs, 1 master and 4 workers. The setup of virtual machines is different between the different hypervisors. I use Proxmox, so if you use something else, please check out how to create VMs on your hypervisor. With 2 CPUs and 8 gigs of RAM per VM, we're talking about 10 CPU cores and about 40 gigs of RAM for all 5 VMs. As my server has 24 cores and 64 gigs of RAM, I could even go with one more worker node. And that is the beauty of Kubernetes. If you decide later on to add another node to the cluster as your workload gets bigger, you can do that anytime. Then you can delete a pod, and if the cluster considers this new VM or this new node the appropriate node, it will then start the pod up again on this new machine. So for now, we will set up 5 VMs. To create a VM, let's switch to our Proxmox environment first. In here, to create a VM, you just click on Create VM. Then you have to enter a bit of information. First things first, provide the machine with a new name. In the field name, you enter whatever name you want to assign to that machine. For me, it's going to be the K8S Master. Once that's done, you can click Next. I already downloaded the image that I want to use, which is the Debian Bookworm 12.1. I will not change anything on the Systems tab, so I can just move on towards the disks. On the disks, I will provide 32 gigs of memory. That should be more than enough to run the workloads on a Kubernetes node that I want to run. Even though we will store all the data from Kubernetes cluster externally, you still need some space for the containers to download, and for that you should have sufficient disk space. That's why I choose 32 gigs, which should be enough to store the containers on those nodes. Proxmox requires you to provide a storage space for those virtual machine disks. As I only have one option, which is the local ZFS, I will just keep that option and move on. Under CPU, as mentioned before, we're going to have one socket and two cores, which is enough for the master as well as the nodes. Once that's set up, we can move on to memory. Memory, as mentioned earlier as well, we will assign 8 gigabytes worth of memory to each of the nodes as well as the master. So change that to 8192 and move on. I have no separation of my network, so there is no VLAN to set up for me. However, you can change that option and set up VLANs for your own implementation if you like. Now that that's done, let's take another quick look. We have two cores, 8 gigs of memory, the name k8s master, 32 gigs of memory on the hard drive, and that's it. By clicking finish, we should now be able to see the new VM being created. Now that the VM is ready, we have to get an operating system on it. As we already selected the image during the VM setup, let's start the VM and let's install the operating system. I will only install a basic system without any GUI. A GUI is irrelevant in Kubernetes as the cluster has its own dashboards and management software if you so desire. I will not focus on these tools and stick with the command line interface. Then simply proceed to install your operating system. Please keep in mind to set a root password and remember that, as we will need it going forward. Once you reach this step of the installation process, please do not forget to install the SSH server. We will need this server going forward, and it's easier to install it right here. Now that the installation of the operating system is complete, we have to set the static IP address before we can switch over to the terminal. To do that, I'm going to log into the console in the Proxmox environment to change that value and to set it up. To change the static IP, you have to go to etc network, and within that folder there is an interfaces file. That file has to be configured in order to use a static IP. I already identified my IP address that I'm going to be able to use, which is what I'm going to set up now. Before we can set up this static IP address, however, we have to be the root user. It is not possible to, as a normal user, to configure that file, so we have to log in as a root. Enter su, then enter the password that you set up during your setup of your operating system, and then you should be able to modify that file. So now that we're logged in as root, you can see the console changed. We can now go vi interfaces, and then we can modify that file. First of all, we have to outcomment the iFace ENS18 iNet DHCP. This is the configuration that lets you pull an IP address from your router or whatever other device you use to provide IP addresses within your network. So we have to outcomment that if we want to set up a static IP. Next, we have to enter another line, iFace ENS18, which is your interface, iNet static, which sets the static IP. Now we have to define and set up three different values. First, the address you want that current system to use, -192.168. Next, you have to define the net mask that within which this address is defined. Net mask and -255. Last but not least, the gateway, which is your router usually, 168. Alright, now that that's set up, we have to save this with hitting escape and then WQ, write and quit. Alright, now that that's done, let's reboot that system now, which doesn't work that way, so we'll do it this way. Now that the machine is rebooted, let's log in and check if the IP address was successfully updated. We can do that by using IP address, and then we see that the address that is now being used was successfully updated. We can now continue using a terminal to configure our machine. To do that, I'm using PuTTY. So once we enter the IP address and hit enter, we can now use the terminal window, log in with our credentials, and continue configuring the virtual machine. First, we're going to verify if the host name is set up properly. We can do this two ways. One, we can already see that it's called KDS master right here. That's a very good indication that it's already working. However, we can also cat etc host name and verify that again. So the host name is already properly set up. We only have to do that for the next virtual machines, for the clones, to change that file. For this one, we're fine and can continue. The next setup step is to identify the IP addresses that you're going to use in your Kubernetes cluster. To do that, let's go to the etc folder, and in here we'll find a file called hosts. This file has to contain all IP addresses and host names of the nodes you will have in your cluster. Now let's take a quick look how the file looks like by default. So cat hosts. So you can see it does not contain all those IP addresses that I just mentioned. As we are going to set up 5 VMs in total, let's add those details to that file. However, we have to be the root user to do that. So we're going to log in as a root user again. And once we did that, I'm going to copy and paste a command that does allow us to add the details to the hosts file. Now that it was added, let's check the file again. Now you can see that I have my IP address range set, including all the nodes or host names of the future virtual machines. Now this file is also set up properly, and we're done with this step of the setup. Before we continue, I want to set up a few things two things actually that will make my life a little easier. For one, I want to install the sudo command. By default, that's not installed, but if I have to execute a lot of commands as a root user, I don't want to switch back and forth. I want to be able to use the sudo command to execute such root commands. So I will set up the sudo package on my system, as well as vim, which I will be using going forward for anything having to do with Kubernetes. So I suggest you do the same thing. So let's set up those two packages. At first, apt update. Let's run a little update at first. I still need to deactivate the image, which is still active, so let's go and do that right now. Apt vi sources.list and out comment the CD-ROM. The CD-ROM, that's basically the installation media that you had for setting up the image. Once that's done, let's run the apt update again, and we should not get any error messages anymore. Perfect. So now apt install sudo. We're going to install the sudo package first, and then we're going to add our current user to that configuration file, which is under sudo-ers, and I need to go vi sudo-ers. In here, you have to add your current user to the file in order to, oh right, and that doesn't work in here, so I have to go nano sudo-ers. I don't know why it does not work as a root user through vi, but it just prevents me from adding a new user here. So we're adding the same line as above. Control O, enter, Control X. Now, if I log out as root and I use sudo apt update, I'm asked for the password, which once entered, now I can actually execute sudo commands. As I mentioned, if you have to execute so many sudo commands, which we will have to going forward, install the sudo package, makes your life much easier. Now we will install sudo apt install vim. It asks, do you want to agree? Yes, I want to. And now we can install the vim text editor, which will also make our lives a lot easier. All files that you can have to configure in the future for Kubernetes will use vim as a basis. It's much easier to navigate through vim, as you can also set certain colors that allows you to much easier identify certain options. All right. There are a few steps we have to walk through before we can set up the container runtime, container D. Those configuration steps is what we're going to do first. So first of all, I have a command that I'm going to copy and paste. So take a quick look at your screen and pause the video in order to set this piece up. Once that's done, enter mod probe overlay, and I have no access to that as I'm just a regular user with this user account here. So I have to go sudo mod probe overlay, and the next command is similar, so just use your arrow up key, take out overlay, and add br_net filter. Once that's done, we can move on to the next step, which is to set up the systemctl or sysctl parameters to be consistent across reboots. Again, it's a little bit longer command. Please pause the video and enter the following onto your terminal and hit enter. So now, if you want to check out if those changes were successful, you can actually go cat etc sysctl.d99 Kubernetes, and then if you hit tab, you just should get auto completion. Once you do that, you get those three values that we just added. Now that that's done, all we have to do is hit systemctl dash dash and system. And again, sudo it is. So now you see that everything was executed properly, and we have those new values being considered. Let's add the sources that we need to our list files so our package manager apt can actually find everything that we need. To start off with, we do a sudo apt update and sudo install the apt transport https, the certificates, curl, and the software properties common. So let's wait for execution here. Once that's done, we have to add the key to our system. Well, because we're going to add a separate or an external source, we have to have a key verification, otherwise our system will not allow the installation. Okay, now that those packages are installed, we're going to add the new key. For the repository in which apt will then be able to find container D, we enter the command with this, which is wget, and we're going to add this and have to figure out if the key was added properly. Alright, as this looked a little weird, let's check out if the key was successfully added. So, in order to do that, all you have to do is just ls the folder user share keyrings, and then you should find a Docker archive keyring, which is right here. So we see it was successfully added, and now we can continue to add the source in our sources.list file. So I'm going to copy the command. Please feel free to pause the video to select and actually I have to update one thing here as well, which is the keyring name. So as we've just opened it up here, this is the right keyring. So Docker archive keyring. Now we should have that in here and we should be good. This source, okay, we're going to do that as sudo user, as otherwise we will not have access. We should have the repository added to apt, and in order to verify that, let's take a look at the folder. cd apt ls, it's not in here. It's probably going to be in the sources.list.d, so let's go into that folder. Sources.list.d, and in here we now find the Docker repository that we just added. Cat Docker list, and this is what we just added. To figure out if it works, all you have to do is sudo apt update, and you should see an entry that is going to Docker, and here it is. Downloaded successfully. There was no error message which would indicate that the key would be wrong. That works. And now let's install sudo apt install container d.io. Alright. The repository is successfully added, container d.io was found, and is being downloaded and installed. Once that's done, we have to move around a few files for the configuration of containerd. First of all, we have to make a new folder. So, as the folder is under etc, we have to go sudo sudo-p/etc container d. Does not want that. Oh, yeah, well, we want to create a folder. Sudo mk directory dash p. Much better. All right, that worked. And now we're going to save the configuration file from containerd. Let's see if that works as regular user, which it won't because we have to copy it into containerd. So we're going to add sudo right away. You can see this is the configuration file for containerd, and this file was copied into the folder containerd was set up. One thing that we have to change is we have to set the runtime environment, or run C, to a certain value to use the system C group driver. In order to do that, we're going vim config toml. Once in this file, we're looking for a certain value. That value is containerd.runtimes.runc.options. Within this structure, we find a value called system C group, and we want to change that value from false to true. Once done, we save and quit. Sudo systemctl. We're going to restart containerd. And we should be done with the configuration of containerd as a runtime. The next step is we're going to set up the Kubernetes library, and then we're going to install the components that Kubernetes needs in order to build a cluster for us. Let's pull the right keys and establish the repository so we can install the components for Kubernetes. To do that, we pull the keyring, and all those details can be found on kubernetes.io, by the way. So we're going to add the keyring to our system. Next step is to add the library. And we're going to work with version 128 going forward. So we're going to add this list. And now let's do a sudo apt update and see if we are able to connect to that library. And if it's verified, yes it is. So that's great. Now that that's done, we can actually apt search for kubeadm, kubectl, and kubelet. Let's see what we can find. Nothing. Apt search kubeadmin. Alright, we have kubeadmin, command line interface version 128. We have kubectl, which is version 128 as well. And last but not least, kubelet, which is also 128. Alright, so we have all the packages we need. At least we found them, and now we're going to just install those. Sudo apt install kubeadm, kubelet, kubectl-y, so we don't have to enter yes. All those items are now pulled, and all the dependencies are satisfied as well. And then once we're done, we have all the components we need to build a cluster on this first node. So let's wait until the installation is done, and we'll go from there. Alright, now that the software is installed, let's clear the screen and continue. There are a few more minor things we have to do, which is we have to configure a few files. So let's get started with the first one. The first one is the sysctl conf. which is sudo vim under etc sysctl.conf. At the end of the file, add, hit I, and then insert the following piece. Doesn't want to copy, so we'll type it out. net.bridge.nf call IP tables equals 1. Write and quit. That's it. Now let's check if that's all in there. Etc sysconf netbridge nf call IP tables. Then we have to deactivate swap, which we do by entering sudo swap off-a. We will also, just for safety reasons, remove the swap from the fstab file, which we do by using sudo sed-i replace in place, and we're saying swap d in etc f the absolute path fstab. Right, let's verify that. Cat etc fstab. There is no more swap in there, so the command seemed to work. And now the next command we have to add is this one here. So we're going to add a 1 to IP forward. 1 and add that to IP forward. Nope. All right, we'll take a look at the folder proc sys net IPv4. And then there should be an entry IP forward, which there is. So let's take a look into that file. Already has a 1 in there, so we don't need to bother adding one. That's totally fine. We are fully set up. Our configuration is ready. And we are ready to clone the machines and then build our cluster, which is what we're going to do next. To clone our machines, we have to go back to our Proxmox. Now that we're back in Proxmox, we can easily clone machine by right-clicking on it and then hit clone. You get a menu, and then in here you have to add or enter additional information. So first of all, the ID, which is I'm going to set this to 111. The next one is a name, so this one would be K8S worker 1. Target storage, the same as the source, and that is already it. There is nothing to choose from the resource pool, so I can just click clone. So now you see machine 111 is being cloned. So the danger now is that it will have, as we set a static IP previously, the same static IP. Two machines cannot have the same IP address. That's why, first of all, I have to wait until it's completely cloned, and then I have two options. One, I can shut down the first machine and then configure through the terminal the second one and change all the details, or I can just do it in the Proxmox environment, which is probably what I'm going to do. It's easier, and yeah, I don't have to worry to shut one machine down, just boot it back up again. We'll let it finish, and then we'll figure that out. Alright, the machine is cloned, so now let's get this one started and let's see if we can do the changes in this machine here without having to shut down the previous one. Alright, I'm going to accept this piece here. Alright, let's log in. The first thing we want to change, and all of the files are under the etc directory, is vim and first sudo vim hosts. Alright, so this is not the KDES master. This is going to be worker 1. Worker 1. So I want to change that. The rest of the file is okay. I just have to make sure that I mention the right name. So we want to write and quit. I'm going to clear the screen, and we're going to now update sudo vim host name, because again, not the master anymore, but we're now working in the worker 1. Write and quit. Last but not least are the IP addresses which we want to change, or the static IP rather. So we're going to go interfaces, and then nope, that's the file. We want to go into network and sudo vim interfaces. We'll want to go in here and change this IP address to 1 because it's my next in line. So my IP address range that I chose, that's the next one. I'm going to write and quit because the rest stays the same. And now sudo reboot now. I'm going to reboot this machine. We'll figure out if the changes that we implemented actually work and that I identified the proper IP range that was still free on my network. And we can actually do that by going back to the terminal. And now I'm still logged in into the master here. So let's see. As soon as the worker 1 is up again, which it is, we're going to switch over again and take a quick look if we can SSH with our current user into that machine. 192.168. The machine is found. So we want to accept the fingerprint. And now we log in. We see that it's now the K8S worker 1. So that was successful. I can log out again. And I have to do this 3 more times. I will not bore you with the same process again. As you've seen it once, you can actually repeat that on your own, and I will be back as soon as I set up all those machines. Okay, I have set up all my machines, and now we have 5 Kubernetes nodes available, 1 master and 4 worker nodes. So now comes the fun part. We're going to join them all into a cluster. Going back to the terminal, we now have to execute a few commands on the master first, which are not executed on the worker nodes. So let's get started. At first, we're going to pull all the images so we don't have to do this later. This is kind of a preparation step, but it's kind of faster if we do it this way instead of waiting during the setup of the cluster. So then let's just kubeadm config images pull password, and then all the images should be pulled and should be available at the time when we want to initiate the cluster, which should go much faster. This might take the one or the other second, so we'll fast forward until all those containers are pulled, and we're going to continue from there. All the images are pulled. Now I'm going to, in my own folder, in my users folder, going to create a subfolder, mkdir k8s setup, and I'm going to create subfolders for each step that we're taking. I'm going to number them so it's easier to actually jump into those folders. So 01 cluster setup, and then in this 01 we can actually then create our first YAML file. So we're going to do that by vim and then call it cluster config.yaml. YAML files are the foundation for the Kubernetes cluster, and all your deployments will be articulated in that kind. So in order to actually initiate the cluster, we have to provide the cluster certain information. So, for example, what's your service subnet? When you create services, what IP address are you going to assign? Pods, what IP address are pods going to be assigned? So those are kind of the information that we need to provide to the cluster when you, at the time where you initiate it. So let's start with the kind, which is the first cluster configuration. Next is the API version, and that should be kubeadm k8s io v1 beta 3. Could be that this option already moved into v1 out of beta, but that's something that we'll figure out once we get to that point. Networking, and this is what I meant with the subnets. So the service subnet, which you define right here, from my cluster, it gets an IP address in its range 10.9600/16, whereas the pods subnet will get an IP address in the range of 10.244.00 and 16. The /16 identifies that there are about 65,534 IP addresses in that range available that can be assigned. We, in this video series, will not have these many IP addresses assigned, but there could be other players like Google, Microsoft that actually use these kind of ranges, and extensively probably. All right, so the first section is already done. That's, nope, it's not. We forgot one entry, which is the Kubernetes version, which for us is v1 dot. And if you paid attention at the previous step, it's 28 v128 0. All right, now that we define that, we want to separate this from the next entry, which is kind, and that's kube-led configuration. And we need the API version, which is kubelet.config.k8s.io/v1 beta 1. What we define here, that's very important, is the C group driver. And we want that to be systemd. Alright, the next one is the init configuration. The initialization configuration, basically. API version is kubeadm.k8s.io/v1 beta 3. Next is the local API endpoint, and we are advertising an address which corresponds to your master node. This is your controller, so your control plane. So you have to provide an address that 192. You have to provide an address that will hand out commands to the cluster, and that other nodes can attach to if they are being joined with that cluster. So 192.16, please make sure that you adjust that to whatever address you're using or have been using, and then bind port, and we will stick with the default here. I will not expose my Kubernetes cluster to the outside anywhere, so that cluster, that 192.168 will never be exposed to the internet. So I'm just going to keep the existing address. All right, with that being said, I'm going to write and quit, and then we're going to deploy that. Now, with that file created, let's initiate our cluster. We do that by sudo kubeadm init config cluster config. All right, let's run it and let's see what happens. We get an error message that this cluster can't be initiated. I ran into this previously, so let's do this again. We have to run one command. Before we do that, sudo mod probe br net filter. Then we have to reset our cluster completely. So sudo kubeadm reset. We will be asked if we want to do that. Answer with yes. Let's see if we need to delete anything manually. Deleting files. Okay. To do so, we must remove this folder here. So let's do that. Sudo rm-r ls etc cni. Do we have a CNI folder in here? No. Yes, we do. So let's look in it again. Okay, it's empty. Anyway, we're going to sudo rm-r, delete that. Okay. And now we're going to try to run this command again. And let's see what happens. Okay, that doesn't look too bad. Your Kubernetes control plane has been successfully initialized. At the moment, we only have one master node, which controls all your workers. But in order to join, you need to copy this command into a document, which you then can use to later on join your nodes to it. So I will do that. As you can see, you also get additional instructions, such as what you should be running, which is what we're going to do right now. Um, so you have access to the cluster as normal user, so you don't have to always use sudo commands, especially when it comes to executing or deploying containers or pods into Kubernetes. You don't want to always run sudo commands, so let's run those commands right now. The first one is already highlighted, so that's the mkdir. So you want to create this folder in your home. And now let's take a look. Let's go back into our main folder, lsla, and now we just created this folder q.cube. Next, we want to copy the admin file into this folder. So we're just going to copy and paste. All right, and last but not least, we're going to make this file owned by our current user. All right, so let's check that file.cube lsla. So the config file is now owned by my user, by myself. Okay. You should now deploy pod network, which we're going to do in the next video. Apply pod network, yes. All right. So now that that's set up, we need to log in into the other nodes and join them, the workers, to our cluster. And we're going to do this from here. I'm going to clear the screen and log into the second node, K8s worker 2. I already tested worker 1 to make sure everything works. So we're going to continue logging into the K8s worker 2. Alright, now that we're in worker 2, we're going to execute the same join command, and we'll see if that's going to work. Alright, now the pre-flight checks will be running, and then we'll see what happens. Alright, this node has joined the cluster. As you can see, it's pretty quick. So we're going to log out from here. I'm going to log into number 3. Not forgetting the password, and we're going to obviously copy the command again. Sudo and run through this whole thing again, running pre-flight checks, waiting for the bootstrap, and here we go. Alright, number 4. Oh, wrong password. Alright, we're going to run the join command on worker 4. And here we go. we should be done any second now, and we are. Exit. Alright. Now we can verify if the cluster is set up properly, if it's built, by executing the command kubectl get nodes. By doing so, we can see we have a master, which is highlighted as your control plane. You have 4 worker nodes. You see the version that you're using, and the status is not ready, which is totally fine, as we still have to deploy a pod network. We will discuss the process for that in video number 3 and continue setting up our environment. So, for recap, what's working? We do have a working cluster with a control plane and 4 worker nodes. What is not working yet? We cannot deploy anything yet, as the cluster is in a not ready state. What is left to do? We still have some work to do to set up our infrastructure, which we will continue discussing in the next video. Keep an eye out for that, as we will be setting up the pod network and bring the cluster into a ready state. Until then, thanks for watching.